Everyone, thank you for joining us here today. Obviously, we're recording in progress, so uh, we're used to that. Thank you, everybody, for joining us today. My name is Larry Waters. I'm the president and founder of Electrify My Home up here in Northern California, where we do nothing but take out gas and put in super efficient little electrification systems. So our customers sip electricity instead of guzzle gas, which is really pretty cool. And we make really, really comfortable homes. And we're going to share a little bit of that with you today with a couple case studies, just so that you know I'm not just some guy. I've actually been a HVAC tradesman since 1982. I've done commercial, industrial, just regular commercial, then residential for the last 25 years. And graduated from UTI in 1982. If we got any alum out there, hey. Been in the trade a long time, 42 years since the first cordless drill, before the first cordless drill was invented. NATE certified technician for 24 years. Still carry NATE certification in heat pump and heat pump installation. 2009, 2010, I earned my BPI certification, and I've been tightening up houses ever since then. I was the kind of guy that if I learned something new and it was better than what I used to know, I can't go back to what I used to know. So it was kind of a curse and a blessing for me. I've only been installing the heat pumps since 2015. We started tightening houses up to the point where we couldn't find furnaces that were small enough anymore. So heat pumps were a good solution. And just to set a clock on that, 2015 was way before the word electrification or decarbonization was part of the kitchen table vernacular. So we definitely have some experience doing this. We tried to figure out the actual number a couple of weeks ago, and we're somewhere pushing 1,000 heat pump systems over these 15 years with me. I started this company, Electrify My Home, in 2020, and we put in like 300 or 400. I don't know. We didn't get close on that number, but lots and lots of heat pumps, lots and lots of custom designed heat pump systems. Today, we're going to do the introductions, which we did, and we're going to talk a little bit about the path towards electrification. And as contractors, if you're contractors out there, homeowners out there, whatever your kind of whatever vision you're looking at this from, there's going to be some information here. If you're a contractor, maybe the takeaway is to offer some of these items that we're going to show. If you're a homeowner, you should be looking for a company that has the ability to give you some of these things we're going to be talking about today. We're going to talk about the things you should consider when you're electrifying a house, and we're going to show you a really cool, a couple of really cool case studies at the end, and then a customer interview that we did and her reactions to what we did to her house. Excuse me. Our mission statement is everything is wrapped up in our mission statement. Is to provide the most efficient, cost-effective electrification solutions to California homeowners, practice good stewardship of the electrical panel, which what that means is we electrify a lot of houses on 100 amps, a lot of smaller homes by using different methodologies and different kind of tricks and devices. And the other part is to train and influence other contractors to do the same. That's part of what we're doing today. We also do webinars for SMUD, Southern California Edison, PG&E, and we also have a deep dive training program through Tech Clean California. If you guys want to learn a lot more, that's a 3-day course. It is available all over the state. You just got to go on the Tech Clean website and find that one near you. The path to electrification. So we have this symbol that comes up. We do everything a little differently here. We do all of our contacts with our customers initially are done virtually. And this is the symbolization that we have of customers taking things at their own pace. So the electrification path, what we want to do is make sure that we're doing a gas assessment and inventory. So look at the existing gas usage bills. You can get that on SoCal Gas online portal, the Electric SCE Energy Manager. If you're a PG&E contractor, PG&E has a really good website for being able to track your energy use. And then Home Intel in the PG&E territory as well. This is a great program if you're operating in the PG&E electric territory. that you can actually have people go in and fill out some information, and it'll give them a nice idea of where their energy is going. Second thing we want to do is build a list of all the gas appliances in the house, take that inventory and figure out what the total path of the customer moving forward will be. And there's several gas loads we want to look at, and furnaces, water heaters, ranges, obviously dryers, fireplaces, and pool heaters. The pool heater is the big kind of game changer on it's hard to get a heat pump to heat up a cold pool, but a heat pump will definitely keep a pool warm. So talking to a guy at a gathering last night from Santa Barbara looking for a way to heat his pool electrically, and that's not 100% yet. Okay. So the electrification roadmap kind of take into consideration all of these things that could possibly be gas, and the different solutions that we have for helping them upgrade, and doing kind of the simple stuff like, did we do the lighting first, right? So did we do all the low-hanging fruit things that we can do first, and before we get into the big electrification measures? But sometimes people start with a heat pump, or they start with a heat pump water heater, but wherever they start, there's these basic 8 things that they have to electrify their house more efficiently. Planning your budget with customers is really an important step that we do. And so we kind of lay this out to the customer as like, if you're going to completely electrify your home, there is going to be some ongoing investments in certain things if you want to get completely electrified, and you want to chart a path for your customer for this. One of the things that we do is when we do our gas inventory, we'll let them know in their existing electrical panel, is this going to work? And at what point during their electrification journey are they going to have to increase or use some other technology to stretch their electric loads? If you want to be a good contractor out there and do this, you should have some experience in assessing panel capacity. And I'm sure most of you guys, if you're hustling air conditioning systems and putting them in, you probably have a decent understanding of this. But electrical panels, there's just a lot of power in there, and most of the time that power isn't all being used at one time. So there's some good derations of the actual capacity that what you see in the panel. And there's usually room in most panels, unless people have done crazy stuff. When I say crazy stuff, it's not that crazy. Familiarity with replacement options for all gas loads. And we don't sell heat pump dryers, or we do sell stoves to a fair degree. But just understanding those replacements, those energy efficient and standard energy use replacements for all the gas loads, so that you can effectively communicate those to the customer. Understand the complexity of running circuits to new appliances that are going to be transitioning over from gas. One of the things we do in a lot of houses is pre-wiring. And so getting the circuits ran to the stove and the dryer and the water heater, if you're not doing the water heater at the same time, upsell that job, put those electrical circuits in, so that when those things fail, you can just go plug a system in. I have a customer, like this week, we're trying to figure out a way to get his heat pump water heater in the next few days. And he has a gas water heater that died, and the infrastructure isn't all there. So it's a little bit harder for somebody to get a heat pump water heater installed if the electrical's not there. If it is there, it turns into a one quick half-day job for a couple guys. You should be willing to do some sort of a manual J calculation with room by room airflow. If you don't know, we use RightSoft, manual J, and manual D. That program takes a little bit of you got to do it a bunch of times before it gets smooth and easy. And even then, you can run into a snafu here and there. There are companies out there that will come and do the load calc for you, look at everything, and kind of do an on-site. That's a bit expensive. There are other companies that you can take down all the information and they will do the load calc for you. And then I just saw the Cool Calc program now has a room by room load feature. We're going to be trying that out next week and see how well that works, comparing it to a write soft program and see how close it is. But there's a lot of different technologies out there for doing load calcs now. When we're putting in heat pumps and we're reducing heating capacity dramatically, we need to be aware of what's going on in the house. Understanding and maximizing energy efficiency through downsizing, because due to the improvements in the thermal envelope, and specifying correct equipment. You should, if you're a contracting business, you should have access to a couple of different brands of inverter heat pump systems, mostly whatever your main brand is. There's a lot of the companies out there have a pretty good lineup, but not all of them do everything. And it's really important to understand like ramping capacities and things like that on these inverter systems, because they're very different in the way they operate, both speeding up and slowing down. And pull permits, like you need to pull permits to do jobs with 3C RIN and get any kind of incentive. So the incentive programs are really driving more people to pull permits, but this is something that we should be doing. If we're going to do an electrification project in the house, we should be doing it with permits. The order of operations here, we'll talk a little bit about that. Every home is unique. And I use the example of my neighborhood. There was, they built my neighborhood in 1978. And there is 4 different house models in that neighborhood. And I have done a ton of houses in every model. And I found that my particular model house has a different load calc than the exact house across the street. Because when we do room by room airflows, you know, the afternoon sun is hitting my front window, the afternoon sun is hitting their back window. This is going to change what the requirements for the load is. And then like we see a lot of people going in and just doing like for like swaps. We don't want to do that if we can help it. We want to make sure that we know the room by room airflows. And then we want to make sure that we take the strategic approach and look at the safety issues in the house first. Look for those problems that could be causing issues such as asbestos, obviously. They don't have any of these in 1978 houses, but they do have a lot of these in 1978 houses. There's a fair amount of rodents going around everywhere. So rodent trace, mold, asbestos, or just electrical problems in the attic space that you don't want to cover with insulation, ventilation issues. Like this one right here had the gambit, right? This particular house had rodent trace. It had non-vented bath fans, and it had electrical that was not in the junction boxes. So my electrician actually went out to this house the first day and spent about a half a day just boxing up and putting all of this wiring into the correct type of junction boxes so that when it was buried, it was going to be safe. Number 2, do a really good electrical panel assessment. We know that there's certain panels out there that are notorious for having problems, like the stab locker or the Zinsco, or if anybody ever seen the Switchmatic, the Pushmatic systems, those might need to be replaced just because of safety. But electrifying an average home with a 100 amp panel is completely doable. Would I do it on a house like this? I mean, I did my house, I electrified my house on a Zinsco panel. I've since changed out the panel last year because I went with a span at my house so that I could do the car charging. And but there are some times when we have to change out electrical panels. Last year, we did 125 inverters, 35 hybrid water heaters, and 11 Sanco systems, and only changed out 6 panels. So we want to look at it, what the incoming service level is. Obviously, that main breaker, can the wire support a 125? A lot of times when it's 100 amps, if it's not aluminum, we can support a 125 amp circuit. So that helps give us a little bit of breathing room. Whatever the main panel amps are, some of these panels are not rated for 125 amps. The bus bars are only rated for 100. So that kind of knocks that out. And we end up using different strategies. We want to look at the age of the panel, the condition of the bus bar, if there's any evidence of burning or arcing, and is there any physical space, and what is my leftover capacity. We all know those customers' houses where they've got all these electric loads in there, like they got the spa, they got 4 refrigerators in the house, and those are the ones that are calling saying, I have a high electric bill. Can you help me figure it out? They're some people are just going to have a high electric bill unless they offset it with solar or something. And then perform an NEC load calculation. If you guys don't know how to, or you people in the audience don't know how to do a National Electric Code load calculation, there's a lot of tools online that'll help you with that. You'll find once you do a few of these that there's a lot more power left in the panel than you thought there would be. So we don't always want to replace panels. People are starting to get this. We've talked to several utilities, and now they're seeing very low percentage rates of panel replacements now, since there's all these other kind of tricks and pathways that we can use. And the outcome of doing this part is we can help plan the panel upgrade. So we did a job recently, and it had a stab lock panel. The panel was not at capacity. They're going to put solar and battery up in 6 months, so they're going to be getting a new panel, but we were able to drop our heat pump into that existing panel, left enough wire there under the house for them to pull the new wire up into the new panel that will be installed somewhere in 6 months. And we were able to get those people heat before the end, just by knowing that there was capacity available on their old stab lock panel. We did look at the panel pretty carefully and make sure that there was no arcing or anything. So the other thing is really important is to pay additional attention to minimize electrical loads. And we'll talk a little bit about that in a minute. The other thing we were talking about just a few seconds ago was pre-wiring to be electric ready. We do a lot of these jobs where if we're doing the heat pump now, heat pump water heater later, we'll go ahead and pre-wire for that water heater on the job when we're there. Once again, if that water heater fails during the time that they're waiting to get their new one installed, they're up and ready to just plug in. Most replacements are replaced on burnouts. The stove, oven, and dryer are also things that we will run circuits to. And we'd use these kind of cool circuit sharing devices, which I don't think we're going to go into on this webinar, but it will be covered in one of the subsequent ones. But there's these things called simple switches or neo charges, where we can plug them into one outlet and share a circuit between a dryer, say, and a car charger, or a dryer and a heat pump water heater, something like that. So there are options out there for stretching that capacity. And there's another one called a simple switch, is like a hardwired solution. And we have several projects out there. Pacific Gas and Electric takes a long time to get panel upgrade approvals in some applications. So we will install a simple switch in the house that perhaps runs the stove circuit, and then we'll rob off of that stove circuit and run our heat pumps. And anytime the stove isn't running, the heat pumps will run. And really, we're thinking that a couple of them we have out there are only going to be a problem on Thanksgiving Day if they're cooking for the whole family. Obviously, the heat pump's not going to run while the stove's on for the whole day. But usually the stoves aren't on for the whole day. So that's a biggie. The ductwork in the system is the most important part of the system. We get kind of caught up in selling units that are, a high SEER rating, and we're talking to our customer about like your old one's a 14 and this one's a 20. Mathematically speaking, you're going to be reducing your capacity, or your overall energy use by 40% or whatever the number is. And then we go and put these systems on the old duct system. Most of the time, the guys out in the field are not checking static pressure. They're not looking for things like thermal bypasses, or what can be a poorly executed sound loop, or whatever the reason for something like this would be. But distribution systems are the biggest robber of energy in the whole system. And if we take a box out and we pop a new box in and we don't pay attention to this, all those efficiencies we talk to our customer about are going to be worse. Equipment nowadays is way more susceptible to high static pressure than it used to be, especially if you guys are installing like low NOx furnaces. We know those things are really, really touchy. They need to have the right amount of air going through them. They burn extremely hot. It is really important to get the right amount of airflow over there. So increasing return air sizes, paying attention to the ductwork. If you've got a massive amount of uninsulated ductwork in the attic space, there's a lot of thermal losses we're going to get through this. So really just pay attention to this. This is the big deal. We've found if we go to a 3-ton system and we check static pressure and it's running at 1 inch of static with a 1200 CFM blower assembly, and really we check the fan tables, we can see that at 1 inch of static it might be doing actually 750 CFM. I would be way more likely to just pop a 2-ton system in there, because I know the ductwork is adequate for 700 to 800 CFM, and I'm much closer on capacity. And that unit's going to work much better because it'll run longer cycles, and it's not going to have those deficiencies in operating capacity that you will with high static pressure. So static pressure is a huge problem. The other thing on heat pumps is we want to use the right type of grills and get the airflow right. Use high flow return air registers, increase the return air sizes. Anything up to 3 tons, we should have 600 square inches of return air opening to keep the velocity low so that we're not making noise, 1, and causing drafts, number 2. And then we solve all those not enough airspeed, not enough air, and make sure we use the right registers so that we're not blowing the air on the occupants. Improving the envelope is something that we do a lot of. And this picture here that you see on the left, we have a lot of craftsman houses in our housing stock where we're close by. And these craftsman houses with the built-in china cabinets and bookshelves, when you go up in the attic and look down, you see this, right? This is the top of that bookshelf or china cabinet. And what you see here in this picture is some insulation contractor came in here and did a pretty fair job of insulating this house. Like, everything is tucked in. There's no places where it looks like it's going over utilities where there would be a gap in the ceiling. And they kind of fitted around this pipe. It's all between the rafters nicely, except for here. But then the people put this in here, and did they just not realize that this is all the same exact thing as the uninsulated ceiling, and it should either be sealed or insulated? What we would do in this particular case is just seal it up with foam board and foam it in so that it becomes part of the inside of the house instead of it's connected to the attic space. Another biggie is on any house that was built before 1995 that has a crawl space and a bathtub is going to have this problem if it hasn't been fixed by someone before you. These holes underneath the houses hemorrhage cold air. When we put a really small heat pump in, we no longer have our big giant furnace with all the waste heat available. With big giant furnaces, we don't recognize these problems because we've got so many BTUs coming to the house so quickly. When we talk to our customers, they say it gets really warm in here and it gets really cool in here really quickly. A lot of that is because of things like this. So go under the house, take a peek, foam these things in, foam in those pipes and wires coming up through the bottom, and stop that cold air influx from the bottom. If you happen to be working in a newer home that has drywall, if you can, sometimes it makes sense, especially if it's batt insulation and you can just move it, is to seal over the wall caps. When these houses are put together, this wood is very green, and as it dries out over time, and it usually dries out pretty quick, as it dries out, it creates gaps between the stud and the drywall, and that allows air to get down inside the walls, which causes infiltration. Then when the wind blows or the hood fan is on or something that's causing a pressure differential inside the house is just pulls air in from kind of the nasty places like your attic and your underfloor. So sealing up these spaces is very important. We want to make sure that we take care of all the low-hanging fruit, like these big holes, and that gets us really, really pretty far in making the house much more efficient and energy, it uses less energy, obviously. Then insulation. We insulate all of the attic spaces in the majority of our homes. I would say that there's probably 10% of the houses that we do or less that we don't actually add insulation and get them up to R50. R50 is kind of the sweet spot. I don't know if you out there know that R value can be translated in heat transfer per degree. So when we're talking to our customer about the attic space that has the rafters showing, and this might be R13, the way we talk about that is as soon as the attic is 13 degrees warmer than the house, we're starting to push energy down through. And if we've been in the business, or we've been up into a hot attic space in the summer, we know that there's not much time up there where the attic space and the house is neutral. As soon as that sun starts hitting, the attic heats up really quickly. And even in the wintertime, these attics can get up to 95 degrees. In the summertime, it's anybody's guess, 150 sometimes. So by installing R50, I've got a 50-degree differential blanket between the inside of the house and the outside of the house. So, or the inside of the house and the attic space. So if I'm heating my house, or excuse me, cooling my house to 75 degrees in the summer, it has to be 150 degrees or 125 degrees in the attic before I'm moving any energy through the ceiling. So consequently, in the wintertime, if I'm keeping my house 70 degrees, it has to be 20 degrees or lower in the winter for any heat to move up from inside. So insulating the attic space is a super important thing to do. Also, it gives us the benefit to make things more efficient. The housing stock near us, there's a lot of houses with ductwork in the attic. And there's a ton of houses that were built between the 60s and the mid 70s that have KD pipe ducting just covered with yellow fuzz insulation. The ones before that were KD pipe ducting back in the 60s, 50s and 60s, KD pipe ducting with asbestos. That insulation on that ductwork is not very good. And so if we have that ductwork up in the attic floating around in the hot air, our system has to have additional capacity to offset that. And so what we do in most of these houses, and I'll show you how to do it here, is we can tell the customer how much load capacity is being utilized to keep these ducts neutral when the attic is hot. It's a pretty easy equation here. So a Building Performance Institute standard is, if you have ductwork in an attic space, and predominantly you have a unit in the attic with your return and supply in the attic, or you have a unit in a closet and your supply ducts are in the attic, the unit with the return air in the attic is going to have a slightly higher number. But if we were to take all of that ductwork out and slice it down the middle and measure the inside of it, it comes to between 38 and 42% of the actual square footage. So what that means is, and we're going to use a nice easy number right in the middle of 0.4. So if I have 1,000 square foot house, I'm going to have roughly 400 square feet of internal duct surface area. If I have a 1,500 square foot house, I'm going to have approximately 600 square feet of internal duct surface area. So we can do the math on this. If we have a 1,500 square foot home, and we're going to be a very conservative number of 125 degrees in the attic, if we're trying to cool our house to 55 degrees under the common assumption that we're going to have a 20-degree temperature split with the coming out of the system, I'm pulling in 75-degree return air, I'm putting out 55-degree supply air. So these are the numbers we use. This can also, and this is conservative. So some of the other people in the building performance kind of arena are using a more realistic number, like the hottest day when it gets 140 in the attic. But this one is a more accurate, in my opinion. If we have metal ductwork with yellow insulation around it, or we have asbestos around it, or we kind of have old R4 ductwork, but there's uninsulated Ys, or it's just kind of falling apart, we use R3 insulation as our divisor here. So if we have R3 ductwork, we take that 1,500 square foot house, we times it by 0.4, that's going to give us the internal surface area of the ductwork. And then we multiply that by the temperature difference between the attic space and the air going through the ductwork. And then we divide that by the insulation value. And then we're going to get this number. So 42,000 divided by 3. That's going to mean 14,000 BTUs of capacity are going to need to be replaced into the system just to keep those ducts neutral when the attic is 125 degrees. So that's a lot of capacity. We can really gain some of this back very simply. If we take that ductwork and hopefully we replace it and put ductwork in that's been sized properly for all the rooms, and it's nice, and we lay it down flat on the rafters and we strap it to the rafters. Remember, your inspectors are going to say, we want those ducts strapped up. Well, the inspectors just want the ducts strapped. We have to strap them to the ceiling or the ceiling rafters. But when we do that, and then we go in over it, and then we bury it with R50 insulation, any of the ducts that aren't coming out of the top of the insulation, which would probably just be the return duct, depending on what your configuration is in the attic space, is we're going to get really good insulation R value on all that ductwork. So if we can average an R30 on the ductwork, and remember, if a duct is sitting on the surface of the ceiling joists, and we have insulation, 17 inches of insulation in the attic, and I've got an 8-inch duct, which is approximately 10 inches around, I've got a good crown of insulation over the top, and I've got really infinite insulation around the sides and down at the bottom. So we can average R30 really easily on ductwork in the attic when we bury it. So what we do is the math again. Now we're down to 1,400 BTUs being utilized or being required from the system to keep the ducts neutral. At this point, we've saved over 1 ton of cooling capacity. So on a typical 1,500 square foot house with old ducts in the attic space and a 3-ton system, which is what it would have had when it was built in the 70s, we can effectively now reduce that by at least 1 ton just based on fixing and burying the ductwork. So really easy thing, makes the house more efficient as well. There's a secondary benefit to this as well, which is when I add R50 to the attic space, I'm also getting less radiation down through the top. I don't have that slide in here, but in the same 1,500 square foot example, if I go from R13 to R50, I'm now reducing my ceiling load or my ceiling radiation by over 6,000 BTUs an hour. Typically, if I have R13 in the attic space and my attic is 125 and my house is 75, I'm going to move about 7,500 BTUs every hour via radiation down through the ceiling. So we're going to be able to capture that capacity as well. And so it's not untypical for us to put an 18,000 BTU system in an old 3-ton house if I've insulated the attic well, done some air sealing, and buried the ductwork and insulation. So what happens when I have an 18,000 BTU system versus a 36,000 BTU system? First of all, it costs me less to buy that equipment. I'm now presenting them with a premium solution that I can charge more for. So my profit margin comes up a bit. And then also I'm going to get an incredibly happy customer because I'm going to be installing a system that you can't hear operate, that is going to use a fraction of the energy. And when we use the right modulating technology, it's going to keep their house at the same temperature all the time. And it's just going to sip electricity. So doing just these things can help reduce the load on the grid. It can help reduce the customer's individual load. And by downsizing that equipment and putting in inverter equipment, we typically use ducted mini split inverter systems. And those usually have one breaker that runs the outdoor unit. So I'm now gaining breaker spaces and gaining capacity that I can use on other electrical loads in the house. So that's what the good stewardship of the electrical panel is about too. We call this whole methodology good electrification. So number 7, perform a load calculation. Like there's several types of load calculation software out there now. This is an interesting load calc I love to share with people. It seems like my neighbors are doing something very loud. I apologize. This is a house in Fairfield, California. Fairfield, California, the design temperature is 99 degrees. And the low temperature design temperature is 34 degrees. So this is a 1,500 square foot house built in 1955, and it had a 2.5 on 12 roof pitch. So I couldn't load the whole attic with R50. We got R49 down the middle, and we probably averaged about R40 in this attic because I was able to get some insulation down near the edge of the rafters. But when we did this load calculation, we were very surprised. And the only thing the customer had done to the house before we looked at it was they had put really good windows in, really good low E, double pane, half inch gap vinyl windows, high quality. And then we came in, insulated the attic, and we were able to take a 36,000 BTU air conditioner and 60,000 BTU furnace out of this house. And we put an 18,000 BTU, I think it might have been a Fujitsu slim duct system in. It actually went back into the closet. Some of those systems can be installed vertically. We put it right back where the old furnace was. Some of this ductwork, the load calculation shows some of the ductwork is inside the building envelope. Some of it had to kind of jump up through the attic and go into the other rooms. But what we have here is two of these bedrooms here. This is the value of doing the proper load calculation. And we have two rooms that are both 9 foot by 10 foot, spare bedroom 1, spare bedroom 2. And one of them needs considerably more airflow. And the way we explain this to our customers is cubic feet per minute of air is one thing we can say. But then I always ask, do you know how much a cubic foot of air is? It's about the size of a basketball. And so in this room, I need 48 basketballs of air every minute. In this room, I need 31 basketballs of air every minute. And then I ask my customer, as I'm showing them this on our virtual assessment, I say, can you guess why this room might need 50% more air than this room? And probably about 15% of the customers we talk about come up with it right away. You have two outside walls, but most of them say, I don't know, the window's larger or which direction it's facing. But just keep in mind, like rooms that are on the corners need more air. Rooms that only have one outside wall need less air. That will help you even if you're not doing a load calculation. If I put a 6-inch duct in both of these rooms and I'm delivering the same amount of airflow or similar airflow to each room, what's going to happen here? This room is going to possibly condition well, and this one will over condition, or this one will condition well, and this one will under condition. So it's really important that we understand these parts of the house that have different exposures need different amounts of air. So when we're putting in systems that run continuously, like they're long running systems, they might run 1 to 2 hour cycles before they actually cycle the machine off because they're really running at thermal equilibrium most of the time. That's going to give us the air mixture that we need in these rooms to make everything super even, but we do have to get the right amount of air into the rooms. So I'm going to tell you about a couple of projects we did. If any questions have popped up, this would be a good place to answer any questions. Alex, any questions pop up?
There are a few, but they've all been addressed through the chat so far. So I think we're good to keep going.
Okay, very good. All right. So here's a case study, Oakland, California. So we're located up in Vacaville, California. So we have about 30% of our customers are in a really hot climate zone, and 30% are and the rest of the customers are in a more temperate climate zone. So Oakland, California is a pretty temperate climate zone, but Oakland, California has broken a couple of heating records over the last half decade. They've had 2 of the hottest years on record in Oakland in the last 5 years. And it's gotten to be over 100 degrees for multiple days in a row, which would be unthinkable back in the day. So most of the people in Oakland, their cooling strategy was open the windows in the evening, let the cool air come in and call it a day. But now we also have this thing called, the wildfire smoke season, which fortunately has not came around the last couple of years. But I know in Southern California, you guys get the Santa Ana driven fires every year. So you get a lot of smoke, people shut their windows. And so when we had smoke days and people in Oakland, Berkeley, and that whole basin there had to shut their windows and live in their house without the natural air conditioning, they realized just how uncomfortable their houses were. And so more and more people are moving towards wanting to condition their houses better. This particular customer, this house is built in 1910. It was one big house for a long time. And then they split it up into 2 separate apartments. It's a co-op ownership. So the person that lives upstairs owns half of it. The person who lives downstairs owns the other half on co-op. They got a really nice yard. The neighborhood is a bit questionable, but they've actually raised the level of the neighborhood quite a bit by all the work they've done. And so this customer was having really high gas bills to the point, and they were so uncomfortable when they ran their furnaces in the house that the lady downstairs just never ran it. She put coats on, she put electric heaters in, she did all these things to try to stay warm, but mostly she just lived uncomfortably. And then the person upstairs had children. She ran the furnace a little bit more. It was a little bit more reasonable the way that system was installed. The downstairs square footage was much less because the garage was part of the downstairs square footage, and they both had the same size furnaces. And the downstairs furnace was I believe it was a high efficiency model. So she was getting more BTUs into the house, but it was virtually like 950 square feet downstairs with a 60,000 BTU furnace in it. It was unbearable for them. And so they had this problem of the front bedroom never got warm because it had dual wall exposure. And on the third wall, it was the garage, and then it had foundation wall coming up. So like they complained when we first came out there is we turn on the heater and this room is always cold. But what we discovered is it wasn't that, it was the rest of the house was heating up so rapidly that there wasn't enough air or energy being delivered into that front room to get it to come up to speed. And they tried all kinds of different things to the point where they just said, I'm going to shut this thing off and we'll just put space heaters in a couple places. So we did this job in collaboration with Sean Armstrong at Redwood Energy. And the house, was built in 1901. It's 2,616 square feet total. Their thing is they wanted to be comfortable, they wanted to be safe, and they wanted to reduce energy costs. Their end goal is that they have gone completely net zero. They put up enough solar and battery to completely cover all the loads that we installed. And we had them disconnect their gas meters, and they're now 100% clean energy electric gas meters. It was a nice big job. Fortunately, this house had a really nice 200 amp panel. When they did the split of the two units, they put 200 amp panel in. But unfortunately, both of the sub panels were 100 amps each, and they were buried in the walls of the condos. Like the upstairs one was in the laundry room on the wall in the middle of the condo. Very, very difficult to run any kind of circuits in and out of. So we ended up doing some very creative stuff. But the first solar guy that came looked at it, and multiple contractors that came and looked at it first said, you have a 100 amp panel here and it's almost full. There's nothing we can do. Like, you're at capacity. And we went out and looked at it, and we did the actual calculation on it. And these things were like at 8,000 watts. The only 220 volt load was the dryer in each one. And it had a 100 amp wire going up to the space. So getting kind of ill-advised by a couple of contractors that came in before, they thought that they were kind of at their wits' end. And remember, they were going to add solar and batteries to this house, so that was a big deal. They were kind of unique as these two share one electrical meter, and they just split the electrical cost every month. They did have two gas meters, if I remember right. So we were able to take some of our loads out of the main panel outside, and they're sharing the cost of those loads because it was easier than trying to fish wire from an interior wall. But the part of that was interesting to me is that a couple of contractors like scared them to death. Like, you have 100 amps here. Even the solar guy that came out said he overestimated the amount of solar that was needed on this house dramatically because they had 200 amp sub panels, and it just didn't make any sense when you know how to actually load out a panel. This was the downstairs furnace. It was a 95% Bryant, a little 60,000 BTU model. It may have been a 40,000 BTU upstairs and downstairs. Return air is kind of floppy. The bedroom that was in question that wouldn't heat was right behind here. The wall cavities here weren't done too well. It was just a system that was thrown together by the contractor that remodeled the house. The upstairs system in the attic, I got a little edge of it. The furnace was a little bit older. The ductwork was all exposed in the attic space. They had R30 insulation, but it really wasn't perfect. It wasn't installed really well. There was some issues with the way that they transversed some of the ductwork, but I can't remember if we reused some of this duct or not. But that was the upstairs system. They had 2 existing tankless water heaters. These units were 1 for each. Now these homeowners were sharing one 50-gallon water tank, and when they first got into the house, so I think they were on one gas meter, if I remember right now. They were sharing one large gas tank. The person in the upstairs house had 2 kids, and they would burn out the water in the gas tank. It would take a while for it to recover. So the neighbor downstairs knew when she heard the people upstairs taking a shower, she wasn't going to be able to take a shower for 5 or 6 hours. So then they called some plumber out. The plumber said, yeah, what we should do is put 2 instantaneous gas water heaters in here. So they had 2 huge instantaneous gas water heaters, and they did that just because she wasn't able to get a shower. So now they want to electrify. And so what do we do with these 2 huge heaters? There wasn't enough space in here for us to install traditional heat pump water heaters because there wouldn't have been enough ventilation and there wasn't enough height. So our solution was a little bit unique on that. We'll show you that. So once we sized up the job and figured out what we needed to do, got all the equipment, the day before the job's happening, we're out in the shop going over all of the equipment that's in the shop, got all the guys out there. We're looking at all the various pieces. We're having our debriefing meeting in the morning, and just going over everything before we start the job. Here was our excuse me. Here's our hot water solution. Since they were on one shared meter, we did a cascading Sanco system. These are 2 83-gallon tanks. These are both installed with mixing valves going to the spaces upstairs. The Sanco sits outside. It heats both of these tanks kind of simultaneously. And now these customers never, ever have to worry about hot water. This hot water system installed was like $27,000. This customer was so passionate about not being able to take a shower when she wanted to and sharing hot water with the neighbor upstairs that they agreed to invest just a lot of money into getting it right. So if anybody out there that hasn't installed the Sanco systems, these are a brilliant heating system. This is an actual inverter technology water heater that does all the heating here. These are actually plumbing lines. This is not sharing refrigerant. This unit has the capacity to heat 50-degree water up to 150 degrees at 2 gallons a minute at high capacity. But the other thing that it will do is if the tank temperature just drops down to 118 degrees, this unit will start to come on and it will slowly heat the tank up. It knows by how quickly the water is recovering in the tank if it needs to speed up or slow down. And this is only a 15 amp unit. So if we would have put 2 heat pump water heaters in here at 30 amps each, unless we went with plugins, and those weren't available at the time, but 30 amps each, we would have been utilizing 60 amps of capacity derated to whatever it would have been. But with this unit, it's one 15 amp unit that's fully modulating, extremely quiet, remote right outside the closet, heating up 83-gallon tanks, 166 gallons of water, and keeping everything nice. Another really nice feature of the Sanco unit is that it uses CO2 as the refrigerant. So this was also a selling point for them, is the CO2 refrigerant works really good at heating things. And so CO2 refrigerant also has like a global warming potential of 1. So really, really smart unit for those customers that want to be very, very eco-friendly, but also those customers that are willing to spend a lot of money just so that they can take a shower. We went into this one with 2 Fujitsu systems. These systems are 18,000 BTUs. I think, no, these are 24,000 BTUs. But they have an operating range that is dramatic. So that particular unit has a ramp down capacity of 5,400 BTUs. It will give us 32,400 BTUs at max, what they would never need in this house, unless the house was bone cold and they didn't turn it on for a week. But the big part that we always look at when we're doing our design is what we call the low end modulation rate. So when we're looking for equipment, I wanted a system that could one, be more easily installed in their existing application. So we wanted a convertible type air handler like this. And number two, I wanted one that could slow down as slow as possible. And out of all the brands that we sell, and we sell 5 different brands, this is the unit that actually has the lowest modulation downturn. So this unit will operate at 5,400 BTUs. It's just dramatic when the house is cool or warm, and then we change temperature in the house using a higher level of capacity with the system, depending on what the temperature differential is. As we get close to temperature differential, the unit slows down and tempers the house. And at that point, once everything in the house is the same temperature, it goes into what we call thermal equilibrium maintenance mode. And that's basically when we've turned their building envelope into its own thermal storage battery by using all the furnishing and the walls and the wood and the floors and all that as the heat sink to hold the heat or to hold the cold. My system can operate very, very slowly. So most of the time when this unit is cycling, it's never going over 10,000 BTUs, and it's mostly between 10,000 and 5,400. And with this type of equipment, it's really hard to tell exactly what BTUs it's putting out. So a bit of that is assumption based on energy use. But when these things are running 5,400 BTUs on low, that unit is using somewhere in the neighborhood of 400, 500 watts. So, and the maximum capacity at 24,000, it's using like 2,100 watts or 2,000 watts. So not a lot of energy at all. For you guys that aren't familiar with these systems, but most people are by now, we just ran the power to the outdoor units. The outdoor units feed the power for the indoor units. The downstairs one had kind of a complicated line set, and you can see the upstairs system, we built it back into horizontal. We did end up sealing and reusing most of their ductwork because it was in pretty good shape. And then we came in and buried it all. Changing the registers. If the houses have registers like this, these are not the right type of register for a heat pump. These will blow the air down on the occupants. And we're looking for a different way of mixing the air in the house with systems that run longer. These are called spread registers. And spread registers work pretty good if I have an oversized system that's going to have a very short cycle, because basically it throws a little air over here, a little over here, and a little over here. And so it gets a little bit of mixture on very short cycles. So those registers are okay with an oversized system. But when we put in a heat pump that we intentionally know is going to run longer cycles, we're using these single direction curved blade registers. And the single direction curved blade registers on the ceiling have 2 different benefits. One of them is I'm keeping the air up on the ceiling, so I'm not blowing near room temperature air when that unit is modulated way down, and I'm just heating with air that's maybe 7 or 8 degrees warmer than room temperature. That air is not blowing on the occupants. The other benefit to this is this thing called the Kawanda effect. And so as I blow air across the ceiling, the static holds the air on the ceiling, and it's able to give it more of a jet activity. So it comes out more as a straight line, and as it spreads across the room, it creates a nice Venturi effect that mixes the air at the ceiling. So we get this round mixture in the room. And so typically, since we're putting much smaller systems in, we may have more face velocity here and more CFM, but since it's going across the roof, people aren't feeling it. But in some rooms, we have much less CFM, depending on what the unit is. So that active mixing is really important, and you get that with these type of registers. Also, on return air grills, we always use either cube core or bar type high flow registers. We do not use any stamp register material. As a matter of fact, when I find a stamped register that has been like sent to my office because it was ordered wrong or whatever, I have a nice conversation with my warehouse guy and go, where did this come from? Why is it here? You know, we don't use these. This is what the attic looked like after we buried the ductwork. You can see some of the ductwork under here, but this is what we're talking about, full duct burial. When my duct is buried under this type of insulation, this attic can be 140 degrees. I've got R30 on here. I'm not going to use a lot of capacity. It can be really cold up here, and I'm not losing heating capacity through the ductwork. And now I've also gained the thermal benefit of actually having the R50 in the attic. These units are pre-wired, or we wired them for the induction ranges, which was no picnic. Both of these units, the stoves were on an inside wall. So it would be nice if we could just run conduit down the side of the house, and then we could drill a hole in the house, run the wire through, and be right behind the stove. That was not possible in this house, either one of these. For the attic system, we actually had to run the conduit up the side of the house, bring the wire into the attic, come back around, and then come down through this space, get into the wall behind it, and drop the circuit in the wall and bring it down. It took 9.5 hours to do this electrical circuit. We charged $5,500 for this one electrical circuit because we knew it was going to be a bear, but the customer wanted to electrify enough that they were willing to pay for it. This one downstairs was a little bit easier. These cabinets kind of go over to the corner, which is an outside wall. We were able to come in and come through the back of the cabinets, and then we actually cut the outlet into the cabinet wall down really low. And we were able to get the cord to plug in. It was a bit of a challenge to make that one work. Actually, what we did on that was we came through the cabinet and then went into the back wall in the cabinet, fished the wire in, and put the outlet in the back. I remember the conversation now because the electrician originally wanted to put it on the sidewall. I says, no way, it won't slide in with the cord. So we actually had to run it through the wall and behind it to get the cord to plug in. I think this electrical circuit was $1,800 or $1,900. So they spent just under $7,000 just to get the wiring in for their electric ranges. And they put really cool induction ranges in. So big deal. We ran both of these induction range wires to the main panel outside because there was obviously no way in a downstairs condo with a 100-amp panel on an inside wall, there was no way without us ripping apart the drywall in the house for us to use that indoor panel for anything. So we had to use the outdoor panel for both of these circuits. And then I think one of them, no, they both had electric dryers when we started. This couple of the guys out there getting the work done. It's really important to train up your guys. Contractors out there, you know this, right? We have guys that are fast. We have guys that are slow. We have guys that will take a shortcut. We have guys that will not take any shortcuts. It's important to have these guys work with and understand the teams and have them work together to where they're going to get the most benefit out of it. So, and where the customer is going to get the best product. This happens to be Dominic. Dominic here he's a very young man. He's 23 years old. He started with me 2 years ago, and he was making $18 an hour. He is the guy that he doesn't play video games. He doesn't watch dumb cat videos. Every minute of his day that he's spending it with his phone is learning more about what he's doing, finding out what's going on. He's on LinkedIn talking to other people and telling them about the work that we do. He's posting stuff on his Facebook about the great work he's doing. And he is really a company guy. I started him at I don't want to get into what I pay him, but he's making 2.5 times more than he was making when I hired him 2 years ago. He is a happy camper here, and he bleeds electrify my home. This is Daniel. He's our field supervisor. He is the same way. They love that we're doing electrification. They love what we're delivering to our customers. And Daniel has had experience working at other HVAC companies before. So did Dominic for only 6 months. But when they come to a place where we're doing exceptionally good work and we're solving problems these guys never knew existed before they came to work for us, and they're getting the reaction of these customers turning these systems on and you can't hear them run, and the customer's like, oh my God, and we get these reactions. These guys love that. They're into it for the customer. And so very, very loyal employees. And it's because we do things differently. We don't have high turnover here because everybody's into it and they understand, especially the guys that have worked at other HVAC companies before. They understand how different it is and that we're kind of on a mission to do things and that our customers are extremely satisfied. This is some of the guys out in front getting the whole job staged out, building the custom sheet metal base for the unit that was in the attic. One of the things that we do on every system is, if you see here the April Air 2310 or these, I put the same exact filter on every single system we install. And I do that for a reason. The main reason is the company I worked at for years before I started my own business, they could not figure out if they did maintenance, they couldn't figure out how to get the guy that was out there before to give the filter size, to put it into a computer so we knew what size filter we needed when we went out the next time. So it was and everybody had a different filter. It was just ridiculous. So I said, one of the things I'm going to do when I start this business is I'm going to use one thing for everybody. So if any of my customers call, I can tell them exactly what replacement media. I can ship it right out of the shop. I only need to have one type of media on the truck to go replace these. And they're all 20 by 20, so they fit most of the air handlers or the bases really well. On the horizontal systems that we install that are slim duct, we have plenums that are actually made in bulk, and those transition from the wide slim opening into a 20/20 opening. And so we put one of these on every unit. That has been a remarkable thing to make things much easier for us. So the other benefit of doing this is these are MERV 13 filters. These are also 4-inch media filters. If you've ever stretched one of these things out and look at it, it's got like 25 square feet of particle trapping surface area, and they're designed for 1600 CFM. Most of the time I'm putting systems on here that are under 800 CFM. So these filters are quite effective when I'm pulling the air through more slowly. And in a lot of the climate zones we work in, customers only need to change them once a year because they don't have a high cooling climate. In the other parts near Sacramento, they change them out twice a year. But that was an effective thing that we did that made everything much simpler. If any of my customers call and ask about the filters, everybody at the company knows the model number, has the link in their computer. They can send them the Amazon link, or we can go out and change it for them with a maintenance cost. So that's been hugely successful. These are our favorite thing. These are the gas caps. We love the ceremonial gas caps, right? So we take out the gas, we put on the cap, and we'll tell people all the time, the only thing we would do with gas is cap the lines. And it's a wonderful feeling to be able to say that. The other part is when we cap these gas lines, it's a little bit of a liberation for the customer. Like now that customer knows, like, this is the symbol of not having to pay unpredictable gas costs and wonder how much my bill is going to be because crap that's going on all over the world and gas prices spiking to $3 or $4 a therm. These people don't have to worry about any of that anymore. Now, these customers have also subsequently gone. She did live with her new electrification system for a while before the solar was put in, and her bills went up because she didn't use anything before. Her bills went up significantly. Now they're using only electricity, but they had no more gas bill. But so when she figured in the reduction in the gas cost, her bills went up about 15% per month, going all electric. But she has since got the solar and batteries installed, and she's virtually net zero now. She hasn't got a full year, so she don't know if she's exactly net zero, but she will be. She's got like 12.5 kilowatts of solar on this house and 2 big batteries. So here she is. She's going to tell us a little bit.
Hello, my name is Jay. I am with Electrify My Home. We have Mary here with us, who was one of our customers, and we decided to go ahead and ask her a couple questions and get her feedback on how she's enjoying her new equipment that we installed. So Mary, why'd you decide to go all electric?
We really started the project with we wanted to go solar. We didn't even understand what going all electric meant. The education of the different products to become electric was all learning. We just felt like we were in a time in California where prices are skyrocketing. We didn't know what the future of that looked like. And there were some safety concerns working with PG&E, and we just thought it was better for the economy and the environment.
Tell us about what electric appliances you've had installed.
So we had this miraculous thing called a heat pump. I didn't know how heat pumps worked. So we have several fans on the side of the house, and they put piping through the house with a liquid that rolls through it.
Yeah.
And that's the system. So we got a HVAC system. So we're a 2-unit building. So it was a unique project that you guys worked on because everything was about each unit. So we have 2 of everything.
Yeah.
So we have something for the upstairs and something for the downstairs. So HVAC unit, heat pumps, and the water heaters.
Nice.
Maybe even a couple more things I don't know about.
Can you tell us about how you staged the replacement of your gas appliances?
Yeah. We also had a consultant who partnered with us and Electrify My Home and ourselves to help give us the education we needed. We basically just went for it. We had all appliances installed all at the same time, except for the gas stoves, which are happening as we speak. So the gas will be completely shut off soon.
Awesome.
Yeah.
So you mentioned your water tanks. You have a unique water heating setup installed with the Senko system. How is the system performing?
It's a dream come true, and I know that sounds cliche, but every time we would talk to our friends, oh no, I can't believe you're going to do that. You're not going to get enough hot water. It's going to be noisy. You're going to have this problem, that problem. And none of it was true, because we don't just have one hot water heater. We have 2 83-gallon hot water heaters in a closet, which is right near my office, and I don't hear anything during the day. And it's smooth. In the past, we would run out of water with 1 bath. And now we can take 2 showers and a bath, and it's the perfect temperature.
Awesome.
It's smooth. It's almost like I want to jump up and down and tell all my friends how wrong they were.
Do you feel like your new systems are quiet?
Yeah. It's not just the hot water and the pumps. It's also the HVAC system. They also have pumps and fans.
Yeah.
And that is right at our front door, in a closet next to our front door, and we don't hear that either. And I was also concerned about the vents. As the vents were coming into the house, all the vents were redone inside to create this optimal heating environment, which shockingly worked. I thought this is a strange thing to be fixing. And when it comes into the house, I can hear it. The first day I was like, oh my God, the heater's on. But after like literally 2 days, I don't even notice it anymore. It's just this quiet circulating system. I don't know how to explain it.
How would you describe your comfort of level in the house?
Well, my unit is on the bottom. We were always a little subterranean, and I hadn't even realized it. We just didn't turn the heat on. So it would get really cold, and really cold in our child's room, who's got some health issues. And so we're always trying to navigate, how do we heat a room? How do we be warm at 5 o'clock at night when we come home from work? And it was just cumbersome. I feel like we were, this is sad to say, but almost like living in squalor. We were like living outdoors, but indoors, and trying to save costs on heat. And it was just the first night I hadn't slept that well in like 3 years of living here.
Wow.
Because it was calm, cool. When you're temperate, when you're the same temperature, it just, your whole life changes. It feels different.
Have your energy bills been acceptable?
Right now we're getting ready to let PG&E know we made a change, because right now they don't even know we went electric. And so there's some special rates apparently when you have electric systems. So we're gonna be doing that. But we never had the heat on before. So things went up a little bit, but not noticeably. As soon as the solar's on, that's gonna bring that back down to a neutral cost. So we are eagerly ready to finish the rest of the project.
Sounds good.
Yeah.
Were there any bumps in the road during your journey?
No, I mean, it's always a little dramatic to have, 8 or 9 guys bringing in tons of equipment and sheet metal, but everything was custom done. So they worked in the driveway. Every night was cleaned up. Everything was smooth. And the crew was so friendly. If I had a concern or a question, they addressed it immediately. I've had a lot of contractors I've worked with in my lifetime, not a team has ever been more professional than the Electrify My Home team.
Thank you.
Yeah, you're
That means a
welcome.
lot. How does it feel to be gas-free?
Gas-free. Well, I miss my gas grill, but that's okay. We're gonna fix that. I don't need a gas grill. We'll have another kind of grill. In terms of safety, you know, we had a big PG&E project replacing the main line, which I learned later should have been done 4 years ago. So we were living with like an explosive tool on the side of the house, and that just made me really nervous. The prices are literally tripling, and so we don't have to deal with that. It's great.
Nice. Good. So you've already touched on this a little bit, but tell us about your experience with our installers.
The guys were great, and I say all guys because they were all guys. They were bringing massive amount of equipment in. They were doing a lot of custom work, and they did it like, I think the schedule was 7 days, all day, every day, and they got it done in 5.
Yeah.
We were shocked they were done early. It was just literally the most professional team of contractors I've ever met.
Nice. And is there anything that stood out about your experience with Electrify My Home?
I would say it was the bidding process. We've had so many teams of solar, electric equipment, this guy, that guy. But when Larry came out, he knew immediately. He understood the 2 units, he understood the property. He was very quickly able to assess the situation, and then he remembered everything. He was like, oh, I know what this project is, this is what we're gonna do, this is the best style of equipment. And he was so confident. And I think he was confident because he's just done it a million times.
Yeah.
So that experience really made a difference.
Do you feel like we respected your property?
Definitely. I think especially the neighborhood we're in, it was really important that equipment is put away every night. And I know when you're coming back the next day and you're long days and exhausted, that's like the last thing people want to do. But every night, we put things in the garage, we tucked it away, we swept up. We've got a small dog. He likes to eat all the things. And so we made sure there were no nails and screws and things. And they were very much attention to detail. And that just made it great at night when everyone's gone. We're like, oh, wow, it's not so disruptive. So it was important.
Great. And is there anything else you'd like to tell us?
We're just so excited to finish getting the solar put on here in the next couple weeks. The economics is going to completely change our lifestyle. The amount of money that we're saving monthly is like $500 to $700. So we'll be saving for our college education for our child, and it's just kind of shocking how an adjustment like this messes with your budget.
Yeah. Well, Mary, thanks for having us and letting us come out to your property. It's very beautiful.
Thanks.
Thank you for your time.
Thanks for changing our life.
Yeah.
Well, the key takeaways on this one were, I get actually when I watch that video, it actually makes me a little bit, it makes me want to like get all mushy inside. It's nice to get compliments like that from customers. We try very hard to do great projects and be very attentive. And to have somebody say nice things like that is really cool. As we all know, as contractors, those customers that we have great experiences with can really make our day. And it gives us that high as an entrepreneur, like this is what I'm working for. And then we deal with the other crap of owning a business. So the journey that they just went for it, everything was installed except for the gas stoves, which had happened soon. She mentioned that it was going to take a couple weeks to have the solar installed. We were going to do the solar as part of the original project, but they wanted to do a different device on there that like wasn't UL listed yet, so kind of threw all that into a change. And then she ended up waiting almost 3.5 months to get the solar installed by another solar contractor that was doing it. And they changed the scope a little bit, put a different type of battery on. She wanted future 2-way charging and things like that. So the domestic hot water, it's a dream come true. How cool is that? Dream come true. The unit in her old furnace was the 95% furnace right by the front door. She said it made that signature furnace 95% furnace sound where it sounded like a reverse, or it sounded like a shop vac at the outside wall, and then the inside wall hearing the burners and everything. Now not hearing anything is amazing. Did all the registers for her, and this is the kind of the reaction we get with doing registers for customers. We're oftentimes the only ones that talk about that. So we'll go in and speak with customers about putting in new systems, and we talk about those registers. We talk about the effect and not blowing cold air on you. And most of them are like, okay, but then when it gets in there and they can't feel anything but the temperature of the room, it's a game changer. First night they hadn't slept. That's pretty cool. Now, it is true. I mean, I've had my heat pump in my house a number of years. If any of you guys have the right heat pump solution in your house, you know, it's super quiet and it keeps you super comfortable. So that's what we strive for on all our projects. And we get there by making sure we're putting the smallest system in possible to do the job. And then sizing everything properly on the other end to make sure it provides the right amount of heating. But I can't say it enough. Inverter systems should be sized as small as possible. Like the upper end capacity of an inverter system should match what the load calc says, not the design, because load calc temperatures are very rare. Okay, operational cost. They were paying, when they got the electrical, their bills went from about $300 a month per side to about $700 a month per side. So their bills went up about $125 per side when we put the system in, but now all that's gone once they got the solar in. And she was really concerned that they did a bunch of gas work in the street and they pulled the new gas line into her house the year prior, or when they rebuilt the house 4 years prior. And there was some issues with it that the utility never came and resolved. So she was really happy to get that out of there. Anyway, okay. So that was Mary April, wonderful customer. This is another customer. This is a house over in Oakland. And the reason I like sharing this case study is because this is one of the only houses we've done in Oakland where the cooling load was higher than the heating load. And so very nice house, beautiful, well kept. But here's our actual heat load, right? Our heat load for the house, we needed 30,000 BTUs of heat, but we needed 41,000 BTUs of cooling. And the reason for that is we had a lot of exposed windows with no shade facing west. So that one room in the front needed a lot. And so it was a very unique project because of that. Our original job on this was going to be put a small system in the attic and put a small system downstairs. The way we did the load calc on this, because it was we don't need to go into that. That's a long conversation. Anyway, so the existing furnace was a 92%, 80,000 BTU, 74 kV delivered. The attic was really bad and had massive envelope leaks. Like you could literally stand in the attic and look down over the sliding doors and see the floor below. The insulation had been, several people had been up there trying to do something with the insulation because there was a bunch of different insulation products up there and none of it was installed right. And they were done by contractors. He told me he had never done it. We fixed the attic space and insulated it in 12 man hours. So we got in there and sealed the thing. We had 4 hours of air sealing in the morning and blowing the attic took one guy 4 hours. We also replaced the water heater on this. This was an interesting one. This water heater is kind of on an outside wall, and this is a sealed combustion water heater. So at least somebody, when they put this in there, they knew there was not going to be any combustion air vents in here. So they put a sealed combustion water heater in here. Obviously, we don't need that with a heat pump. This is my junior air sealer, my 16-year-old son out air sealing with me. We're taking care of the leaks in the attic. And here on the left, you can actually see these are the tracks for the sliding doors in this 100-year-old house. And the other thing you can see too, if you're familiar with this, is the coffered ceilings. You can see the curvature of the ceilings coming down here. So there's a lot of area where the walls were just kind of like completely open. And then we had these giant openings here. This house also had two really big, we'll call it drop soffits, where like I showed you in the picture before, where the ceiling was just, or the attic floor was completely open and you could look down on the top of the built-in furniture. The house had a few of those as well. And you could see the insulation in the back. Like somebody had just kind of propped up insulation. It was going over like all the wiring. The wiring had been already changed in this house. As you can see, there was Romex. And they did that so they could insulate it one time. So they changed out all their knob and tube wiring, put in Romex, and then the guys came in and laid the insulation right over all the wires. So there was all these gaps between the lath and plaster ceiling and the insulation, and it was going over framing members, and the insulation was just not installed well because it wasn't making good contact with the air barrier. So we didn't have what we call a complete thermal boundary. And then This is a little bit more what it looked like in the end. We sealed up all of those coffered ceiling joints in the whole space. We went over with duct board and sealant for all of the interstitial wall cavities, and we got the attic super tight in about 4.5 hours and about 15 cans of foam. And I believe we had 3 full sheets of this ductboard material that we installed. And then we blew in the insulation to R50. This particular unit used a Bradford White, I believe it's a 65 gallon Bradford White heat pump water heater. The mini split system was a Mitsubishi on this one. It was, we went with a 36,000 BTU Mitsubishi. When we did this job in 2022, I believe the reason we went with the 36 was because it had a little higher cooling load, but we knew that we did all that work in the ceiling. So we weren't going to put a unit that would match the full cooling load, because, you know, in Berkeley, you're looking at the high temperature load as 96 degrees. And I think I reset it for something like that. Anyway, I can't remember, it was a while ago. We took the house had newer ductwork. Originally, we were going to put a system up in the attic, and we were going to put a really small 18,000 downstairs and a 12,000 in the attic. Well, they didn't want to do that because they figured out, you know, once they figured out we had to put line set up the side of the house is really a beautiful home. So they didn't want to do that. So we just ended up doing a couple of tricks to the ductwork to kind of balance things out, and put this 36,000 in. This particular 36,000 BTU unit can slow down to about 11,000, so that's pretty good. And once again, one wire to the outside powers up the inside. You can see kind of the quality workmanship here. Everything is really nice and clean and tight. Once again, there's my April air filter that I use the same exact filter on every job. We have to do a base on these units because obviously you can't cut into the side of a heat pump air handler. This is the review we got from this gentleman. It says they also provided the needed work for the city inspection in Berkeley. Both the heat pump and the hot water work great and are much cheaper to run. So they're getting a system. They fully electrified. They got away from gas. They don't have any dependency on the unpredictable gas prices that are happening. They're completely off gas. They know what their energy costs are going to be. They have solar on the roof that makes it even better, and they're cheaper to run. The heat pump is also much quieter than our previous gas furnace, and the extra insulation. This is why it's important to do this other stuff. The extra insulation that was added has been a major improvement. Even without the heat pump, our upstairs room are much more stable in terms of temperature, both summer and winter. Highly recommend Larry, Alex, and the rest of the Electrify My Home team. So doing complete projects on these things and putting in systems that work good, it is a great way to do this if the customer's project permits it. I'm not saying that everybody should go out and do all this work, although this is all we do. The traditional HVAC companies, you can transition into doing this type of work and have it be the higher quality project work. One of the things about both these projects I'm showing you and all the other projects we do at Electrify My Home, we do not have a service company. We do not do anything with gas except put gas caps on the lines. And we're not a service company. So nobody calls us to do service calls. I don't have SEO marketing on the typical things like HVAC service, furnace broken, all these things. I don't get those calls. I don't want those calls. If I had a service tech right now that walked in the door and said, I got a sale, but it's an emergency, it's broken, and we need to put it in next week, I would have to tell them, like, I can't, we're scheduled through January. Like, so because we do project work, my customers are willing to wait months to get it done because we don't do emergency replacement work. So once you get into doing electrification and doing these projects, people will wait for them to get done because these are upgrades and construction projects for people's houses. So we can also charge a lot more for them because they're not emergency changeouts, and you're not competing against every other HVAC contractor out there. So any questions here that have come up, Alex? That's the end of our presentation for today. And thank you all for joining. If there's any questions, I can answer them now.
I think all questions have been answered so far.
Very good.
I'll maybe pick one for you to
Okay.
expand on. Let's see. How does electrifying older homes pre-1930s differ from electrifying newer homes? What are the common issues you face? Duct leaks on old systems and typical issues with craftsman style houses were mentioned, but what else pops up? My initial response was that there's endless surprises that come up. But poor thermal envelopes, asbestos, lead, galvanized piping, knob and tube, outdated electrical, and just existing areas that are not up to code. Do you have anything to add to that?
Yeah, I mean, the one of the things that we do on a lot of these, and if you have a 2-story house, and it's got like a basement heating system, we need to understand that if we put in one heat pump on that house, it's not going to condition the house evenly. So it's going to have the same effect as every 2-story house. If you want it to be cool upstairs, it's going to get cold downstairs. We don't like doing that. So if we do 2-story houses, most all of the time we're doing a system in the attic space, and we're utilizing some of our existing infrastructure to do a system downstairs. So it splits it. Another thing that we run into is when they put these houses together back in the day, they ran a lot of the ductwork through wall chases with wall can, and it's got asbestos on it. And when we do a load calc and we figure out what the heat load is on the upstairs rooms, we look at the carrying capacity of those ducts, and we find that there's no way we'll be able to cool that room no matter what with that existing ductwork. So that helps us in the conversation to talk to a customer about, we need to deal with each microclimate zone in your house separately, because there's sometimes you're going to want to run cooling upstairs and not freeze downstairs. And sometimes you might just want heat downstairs and not need it upstairs. So we use that in order to put 2 systems in. The other thing is, when we put 2 systems in, it's rare for us to use ever a multi-zone outdoor unit. We would usually put in 2 small systems, say a 12,000 for the upstairs and an 18 for the bottom, whatever its size is at. But 2 individual 1-to-1, and we try to use slim duct on anything where there wasn't something already there before, because they're easy to install. They don't take up a lot of space. They're not heavy. They need less attic infrastructure. But having 2 systems outside means each one of those zones are going to have that really wide modulation rate, and those units are going to be able to really slow down. If we have 1 unit downstairs and we're trying to tackle the upstairs and the downstairs, there's always going to be a time when these people are not perfectly comfortable. And what we design our systems for: comfort, safety, energy savings, for people that are very eco-minded and quiet. And if I have to put a system downstairs that's big enough to do the whole house, sometimes they're not going to be as quiet as I want them to be. And when we present this to the customers, and instead of saying, I can do this, and what we see a lot is like, yeah, we got 3 bids. 1 guy said we need new ductwork. 2 guys said we didn't need new ductwork. And now you're telling me I need 2 systems. And I said, yeah, that's exactly what I'm telling you, because those guys can't even agree on what ductwork you need, right? So having a completely different solution and going in and being more complete sometimes sells the job itself, right? This guy is taking care of things. He's going to do the calculations. He's concerned about these things that the other contractors didn't even bring up. So it's really easy for us to bring, like, I wouldn't say suspicion, but question of the other contractors' kind of solutions when we're coming up with something that's backed with data and all that. The other thing that we do that's unique is we meet virtually with all of our customers first, and we have a customized webinar for each customer. And so I'm meeting them just like I'm meeting you today. I'm able to show them a PowerPoint presentation, get into extreme detail, and do these things that you can't do when you're doing kind of the old sales approach, where you're trying to like build rapport, look at the picture. No, that's very important. But we're building rapport through the fact that we're looking at their house, and we're applying a little bit of science to it, and we're backing up what we're doing by showing them the actual science in real time. And that helps close those larger jobs where people want the lowest cost of operation when they put their systems in. So I know that was a little more of an answer to that question than you asked.
All right. Well, we're at 9:30. Ian, I think we'll hand it over to you. Larry, if you want to forward the slide.
Yeah.
And we can start closing out.
Awesome. Thank you, guys. Thanks for a great morning, Alex and Larry. Just wanted to mention we did have AIA learning units available this morning. I should have all that information from your registration, but if you are looking for learning units and may have not included your number in registration, please feel free to reach out. I'll be sending out slides and our post-event survey later today. It is an automated process, so you'll either get them in your inbox this afternoon or sometime this weekend, but you will be receiving those. And just a couple of highlights for upcoming events listed here. We've got a few more events through the end of the year. I wanted to specifically call out, we are doing a passive design build boot camp in person in downtown Santa Barbara from October 30th to November 3rd, and Monday is the last day to register. And we have a few slots left. So if you do have the free time and are interested in receiving your Passive House tradesperson certification, please sign up. Check out our website, 3crun.org/events. And otherwise, yeah, just run-of-the-mill webinars. We typically have about 1 or 2 events for you all each week to tune in. And those will all be found on our website. Otherwise, any questions, anything like that, feel free to reach out to me directly. I think Larry and Alex also shared their contact info, but other than that, thank you all for a good morning, and we'll see you at the next one.
Man, you know what? I wish I was down in your area because I would be digging on that passive design boot camp. I would be there if it didn't mean traveling.
Yeah.
That sounds awesome.
Yeah, it's a fun one. It's a lot, 2 days of classroom, but also supplemented with 2 days of hands-on workshop, working with like these little modular puzzles, basically working with, the latest materials and air sealing tech. It's a lot of fun.
Man, that sounds cool. All right. Thank you everyone for joining us today, and we'll talk to you soon.
All right, y'all. Thank you.